Hello, everyone. Welcome to this amazing session. How are you feeling? Hi, Scott. Are you good? Good day, Scott. How are you all feeling today? How's the course been? We're, we're almost there. Are you guys feeling good? Are you guys learning? Are you guys having fun? I know Genevieve is learning, or Genevieve is learning. I know she has learned something. I know Tam is learning. I know Scott is learning. I know, what's his name? Put the pipeline for the restaurants. I know he's learning. Skipping my mind now, but I'll remember. How are we feeling? Are we feeling good? Are we feeling happy? Are we feeling loved? Are we feeling supported? All right, all right. I'm happy to see we're feeling good. We're feeling awesome. Welcome once again to what's the name of this podcast? You guys should remind what's the name of this our podcast? To the Pi Spark podcast. And yeah, today we'll be looking at optimizing now PySpark, optimizing Spark. When we're working with it, remember our code has to be efficient, to reduce bloat, and more importantly, in this day and age where more often than not, in the work environment, you guys be work using tokens, be working alongside with LLMs and the likes. Your code has to be efficient, your workflow has to be efficient. So although this was your price back, your code had to be efficient long before the age of generative AI, but now more than ever, you see in real time how they cost money and how they can save you money. But before we go deeper into this session, I'm your one and only, your beloved host, your favorite, your best friend, counselor, technical mentor, data scientist, um, genius, Kayode John Balogun. Only me, I bear those titles. And I welcome to another amazing session. Um, I hope I'm audible. I hope you guys can hear me. I hope my voice is, if the audio quality drops, kindly let me know in the chat. Yes, if you have any questions, link them to the Q&A section. Enjoy using the chat, but don't forget to be respectful while doing it. Listen, learn, and engage. The engaging is if I ask for emojis, you drop those emojis. If I ask for response in the chat, you say, hey, respond in the chat. So let us begin. So Tam, kindly explain what the analysis exception error is all about. Don't mind me. I'm pulling your legs, Tam. Oh, it's all cool. I hope I surprised you. Yeah, we have fun. We have fun. So I'm setting the errors here because as usual we'll be writing code and I just want to jump to the code. I wanted us to just go through the two slides, talk about the errors. Optimizing Spark, trying to reduce things that might make our PySpark fail during the process, among other things. I'm sure Tom will never forget when I called out to explain something. Well, it's cool. And then focusing on troubleshooting and scaling a key component of our optimizing. So before I start, okay, discussing all these errors and looking at them, I want us to use the analogy of a restaurant or a kitchen for PySpark. The driver is the head chef. It sits at the counter, it plans the menu, it breaks down customer orders into step-by-step tasks. The executors are the assistant cooks. They work at separate kitchen stations, chopping, boiling, and frying data in parallel. Lazy evaluation, you're writing the recipe first. When you tell Spark to filter or transform data, the head chef doesn't start cooking immediately. They write down the instruction on an order slip called a DAG. I hope you all remember what a DAG is. Can you let me know what a DAG is in the chat? Looking at you, Tam. Shego said you ordered the fried one. Damn, what is a DAG? I finally called you now. Anybody else can answer, even though I've called Tam. What is a DAG? If not, I'm not. Thank you very much. Thank you. Thank you, Genevieve. Our directed acyclic graph contains the written instructions. Yes, well done, Tam. And cooking only begins when an action, for example, like serving a finished plate with our dot show or dot count is ordered. That's when the cooking starts. So we can now begin to look at our errors. So things go wrong. Sometimes things go wrong in the kitchen. Spark, shout, an error. And here's what those error messages actually mean. So we can say we see our Pi 4G Java error. What happened? The assistant cook panicked in the back room. That is the Java virtual machine layer, JVM layer, and then passed a generic error note up to the head chef. How do you go about fixing it? We scroll past the first few lines of the error message to read the bottommost cause. So the very last error message at the bottom is what you read to see what the real issue is, because the assistant cook panicked. And okay, very good. So who is our assistant cook? Let me know who was listening. What is our assistant cook? What is their title? The driver is the head chef. The assistant cook is the let me know who I'll give the certificate now and start going. Let me know who was listening. So who is the assistant cook? They are the what? Was I too fast when I was explaining the different rules? When I was explaining the analogy? Was I? Okay. Maybe I'll take it again because the chat is now silent. Uh, the assistant cooks are the executors. They work and in separate kitchens, using like an analogy, chopping, boiling, and frying data in parallel. Frying the stuff that Shegun ordered. The executors execute. They do stuff. So these executors panicked and sent a generic error note up to the head chef. That would be for the head chef. The head chef would taste everything. uh, so to fix this 54J Java error, you look at the bottommost cause. That is just read the error message at the bottom of the long thing that you're going to be seeing in your terminal. Next, we'll look at another error called the analysis exception. We'll continue using our kitchen analogy. In this instance, you ask for an ingredient, i.e. the column name, that isn't on the kitchen shelf, or maybe you spelled it wrong. You spelled it wrong or it's not available. And you fix it by checking your column names and the spelling. And you can use the line df.print schema to just check and analyze that, okay, your column names are what you're asking for, they are spelled properly. And then another error is the null pointer exception. They are is considered using a kit analogy. An assistant grabbed an empty container expecting food inside and tried to slice it. You fix this by trying to clean out empty or missing rules early using the df.na.drop or the df.na.fill. Sorry, bear with me. Aha. Next, our type error where the column is not iterable. Here you are trying to cook an entire crate of potatoes as if it were a single potato using a normal Python loop. Here, you don't use normal Python loop for row in df. Instead, use native Spark functions like df.filter. And then you have out of memory, where too much food was piled onto a single prep table and now is flowing to the floor. How do you fix it? You split big data sets into smaller portions or give workers bigger prep tables in the executor memory. So I think this error forms a core point or a core pillar of our optimizing Spark and what we'll be doing today, scaling in Spark. And don't forget, when you're troubleshooting, you don't have to guess what went wrong. You have three powerful diagnostic tools. One is called log granularity. Log granularity. Yes, sorry, I was kind of tongue-tied. So, using our kitchen analogy, the kitchen can get very noisy, but can control how much chatter you hear using the log levels. You use the line spark context set log level and select info. It will show the kitchen milestones and the stage updates. And then the same thing, spark context set log level, and you want to see error. So you keep the kitchen quiet and it only shouts if something is broken or if there's an error happening. And then the second one would be the recipe blueprint. We want it to explain. Because we're using the kitchen analogy. So before like turning on the stove, you call df.explain. It lets you inspect the head chef's exact plan. You check if Spark can perform smart shortcuts like filter push down, where you throw away bad ingredients before washing them, and column pruning, where you are ignoring unused ingredients or unused columns. And then last but not least, our Spark UI. Have any of you checked out the Spark UI? Let me know in the chat. Has anybody laid eyes on the Spark UI on their own by going through the content? Okay. I know you have, Genevieve. You are already a data engineer emeritus. Tam, congratulations. I think I've given you a certificate a while back. I'll give you a bonus certificate. Here you go. Awesome. So, your UI can help you in debugging. It acts as a visual dashboard showing real-time metrics. You can see the jobs and stages tabs where you track how fast the tasks are finishing. You spot maybe data skew when 9 cooks finish in 2 seconds and one cook takes 10 minutes on a giant heap. You can say, oh, let me reallocate stuff. And where you can see the storage tab, you display saved data sets, stored memory so you can see if the RAM is filling up. The executors tab, where to show the memory consumption and the garbage collection time. You can now realize or see if high garbage collection time means workers are spending all day cleaning up dirty dishes instead of cooking. So if I know that, okay, there's an issue there. And then the SQL tab that displays clear flowcharts of your queries and row counts moving between stations. So these are some of the benefits of using our Spark UI to handle issues. Now we've talked about the errors and how we can go about fixing some of them. We look at first writing code, we look at we'll be seeing the Spark UI here live after we finish. Right now, code are just running. Don't worry, it's not going to be very long today. So after I finish writing, we'll look at the Spark UI and then check out 1 or 2 things. But also, they have some of these concepts in mind. For example, When you want to perform scaling, you do things like partitioning. It's like chopping food into equal slices. You want to keep all the assistant cooks or our executors busy. PySpark breaks the data into chunks called partitions, and you are told to aim for 128 megabytes to 200 megabytes per partition. So, um, when partitioning, there's two things you can do. Repartition, when you shuffle all data across all tables over the network to create equal number of piles. Use this when your piles are uneven, or you coalesce when you combine neighboring piles on the same table without passing, for example, food across the room. So no network shovel, like you are shrinking the small piles down by combining neighboring piles together. And then apart from partitioning, things you can do while scaling could be caching and persistence. Let's say you need to make 5 different soups that require chicken broth. You don't boil the water from scratch 5 times. You boil a big pot once, you keep it warm on the stove, and then you keep reusing. So in PySpark, calling df.persist saves transform data in memory. So future actions will run instantly. And then we have different storage levels, like our memory only storage level, which is uncompressed. There's no disk overflow, and is best used for super fast execution when you have plenty of RAM. The next storage level is memory and disk, and it's also uncompressed, and it's possible to have your disk overflow. It's the safest option. It fits in RAM and spills excess safely to the disk. And then the third level, we have the memory and disks, and then the serialized or volume packed. It has the disk is possible for your disk overflow, and then it compresses data into, it's best used for you to compress data into small byte arrays to save RAM space. And then we'll talk about broadcast join. Normal joins required matching rules to travel across network cables to meet on the same machine. But if you are joining a giant or mighty data set in our big data with a tiny reference table, for example, let's say I'm matching department codes to names, wrapping the small table in our broadcast small underscore df puts a full copy of the tiny table on every worker's desk so that there's zero network shuffle required. So we'll jump now, write our code state by state, explain what's happening, see examples, and then, yeah, once again, carry go, use it as your cheat sheet, and enjoy. So, but before I jump there, are we still together? Is there any wahala? Should I continue? All right. Okay. Yeah. So I'm sure we all know how I got here. Am I in the right place? Optimizing. Yeah. So I'm sure we all know how I got here. Do we? I think every time people again how to increase the size. Let me increase the size a little bit. No, what is that? Is it? Yes. Hope it's big enough. We can all see everything clearly. Do we all know how we got over here? So nobody knows how we got to this part. Nobody knows how to open the IDE and create a file. Okay, thank you very much, Tam. I wanted to collect my certificates that I've given or that I've promised. Okay, so we begin. First, we start with our session builder, build our session, then our schema check, panda CDF, create the plan inspection, do our repetition and coalesce, and then um, implement persistence, and then broadcast join. Yeah. So, may we begin? First things first, we import all the importables. Oh, bear with me. Okay. Okay. And now, so we import. Oh, I'm laughing because I always forget about this guy too. We have sessions, imports, founders as PD, um, PDB, then PySpark, and put a PySpark session. Then from PySpark again, one SQL, one functions that's if and PySpark, SQL functions. Mm, I know. Uh, PySpark, SQL functions. We don't have that. Okay, yeah. Import, we want broadcast, Commander CDF. Okay. And yeah, I want to price back the storage. Okay. Sorry, it's the comma. Yeah, hold on a minute. Okay, from price back to call. Okay, I've seen the issue. Yeah. Okay, from price from import podcast, Commander CDF. And then storage level, import storage level. Uh, okay. Um, so let's initialize our Spark session. Yeah, starting Spark session. Let's look. Oh, no, start our Spark session. I see Spark. Other Spark session. Optimizing Spark. Okay. Spark session builder. Uh, okay. App name. Builder. App name optimizing Spark. Get a create. I want. Okay. Master config. Master local. Uh, big spark dot SQL dot just the shuffle dot partitions. I said partitions correctly. Four. Just check. Um, SQL dot shuffle partition for yes. All right. All right. Then issues will fix them later. Then um next, let's set the log level to info to monitor progress. Remember, we are trying to debug info. Remember what I said when we are using info, what they help us do to monitor progress. What of the steps for debugging or dealing with errors, what is happening. Oh, as I'm talking, my thought process has comment should be set log level to info to monitor progress. Uh, okay, smart context, set log level info. Yeah, standard smart context set level to info. Yeah, exactly. Syntax I mentioned earlier. And then I wanted to print I wanted to let us know print um uh, that session has started. Oh, okay. That session has started. Next, uh okay, let's load in our data sets. We'll be working with employee records. So let's see, load our data set. Oh, the big load our data set, employee records, and we spell employee again. Employee. Okay. Employee records. Uh, employee records. Okay. Can you guys see the suggestion? Can, can you guys see the suggestion that anti-gravity is giving me? Let me know in the chat. Yeah, I'm sorry. The anti-gravity music is still there. Can you guys see the suggestion anti-gravity is giving me as employee records? When I it's kind of surprising though. I don't know if I should be amused. I honestly don't know if I should be amused. Why did it select Coyote as wow? I don't think I've used my name in any of the many data sets I've done. So it's kind of something. I don't know. It's blowing my mind. Don't mind me, guys. Um, it's cool. I think I'll use it. I'll use it. I'll use it. Okay. Um, next. Okay. Wow. Okay. Cool. Um, okay. All right. I think we're good. Oh, no, what happened? Where did you guys go? Sorry, I forgot to accept with tab. Yeah, I accept. Cool. I wonder if there's any James, Emily, David, Sarah, or Michael as learners here. They aren't. Still cool. Um, okay, understandable. Yeah, I don't think there's any bug here, any issue. think I can accept this. So, you see our column names. We okay. Employee. Hmm. Yeah. Create. Huh. No, no. You see why you have to be careful. Okay, okay. Cool. Let me accept this. And then no, I want you to print employee at print what did yeah, that's sure. Okay, let me accept and edit. Print code of the session. Let's print employee data frame schema, and then we want paste it df. I want you to but yes, print schema. Yes. As this suits our purpose more. So next pandas CDF we say, you know, vector CDF. I don't know from last session, can anyone remember how our pandas UDF helps us? Can anyone remember? Let me put in our comment. All right. Pandas underscore UV. Okay. Set. Define calculate bonus salary. Uh, okay. And that's PDF double. Uh, compute bonus. We want salary. Mm, um, okay. Salary finishes. Okay. Get real amount return. Yeah. Salary times 10. Cool. We'll soon be done, guys. And then let's apply calculated columns. Uh, calculated columns is now native functions. Hmm. I typed what I was saying in my head. Native function. Okay, let me just add S. I added the R. Native function. Okay, columns. All right, using a native function. So the div Um, if optimized, okay. Accepted. It's match equipment, salary, vision. Hold on a minute. Okay. Column, bonus, column, side, uh, salary. Okay, get employee ID, employee full name. Okay. Yeah, fix that. Next, let's display the physical query execution plan. So it's visible in our terminal. Um, oh, tab. Yeah, let's display physical query execution. Okay, execution plan trained. Um, okay. Physical execution plan optimized. Yeah, print. Print. Yeah, excellent. Uh, issues with indentation. Three. Yeah. Yeah. And then partitioning and caching. Let's see. Um, partition, partition management, caching. We spell caching again. Caching is a okay. Um, session. Session. Okay. Def partition. Def. Okay. Merge that repetition. Okay. Department. Cool. Accepted. Def. Scope skill. And then underscore partition. Yep. I thought I accepted that. Underscore partitioned. Here we coalesce two. And then for persistence, see we wanted to persist in I know it's a comment, so it's not that serious, but still, I think it's kind of bugging me. What was I? To persist. Yeah, we want persistence, data set in memory, in memory, disk. Should we say DF score scaled persist? Okay. Build up persist storage level. Yeah, we want it in the memory and disk. Remember, we can choose only memory and disk, or memory disk and what you call it, memory disk and what's the third one? Okay, remind me the chat. Serialized vacuum, serialized or vacuum packed. I know that if I wanted the answer in the chat, I'll wait a long time. So this one, just want our memory and disk. And what's the issue here? Definitely go scale my D. Let's say edge level. Okay. Edge level memory and disk. Okay, yeah. I think that was a typo there. What next? Yes. So let's trigger computation and cache a result. Um, Now what at this stage, trigger computation and cache results. Um, mm, 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 oh, what's df underscore scale count? Yeah, cool. And then okay, print total records. Cool. Uh, Next, let's fetch the cache data so we can illustrate. Um, fetch fetch our cache data. Okay. Yeah. Let's go. What was that? Okay, clear from the score. Scale. Yeah. Okay. Next, let's using optimize our join using broadcast. So let's say um let's optimize join using broadcast. Optimize join using broadcast. Let's do broadcast. Okay. See department meta department data. So see. We have um, engineering done. Okay. Good enough for sales. Better. Okay, let me go with this. Sales. Cool. 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 I'm gonna go with this. Just go with this three and take this out. All right. What next? Let's look at our schema. Our schema. Okay, department manager, direct manager there. Hold on a minute. Let me forget the that I've created. We have department age, and then age. Okay. Information ID. Okay. Department manager. Everything. No? Okay, cool. Let's let's look at that. And then we see. Okay. Here, department bank dot create data frame. Department method parameter data. Of course. Okay, cool. Next. We're almost done, guys. I think this was the last one. Let's perform our podcast hash drawing. We perform broadcast. Okay. Ah, hold on. Perform broadcast join. Okay. Okay. They have my broadcast. They have skill join broadcast. They have departments. Department. Yes. On department. Oh, inner. Cool. Yeah. And then print. Okay, broadcast has joined. Levels optimize dot broadcast dot show. Okay, cool. Yeah, almost done. And then let us free up memory resources. Free free memory. Tidying up now. Free memory. Free compressor resources. Okay, resources. And then we say df underscore. Yeah, what was that? Df underscore scale on persist. Okay. Print. Okay. Yes, class one persisted. Spark stop. Print spark session has been stopped. Let me. So technically, I mean, we done. We done. So let's output and go ahead with the explanations. Hopefully, we don't have any issues. We don't have serious issues. Let me move these Zoom menus and icons and Where do I keep this? Okay, let me keep this here. Okay, get that there. Let's run and see. Oh, wow, you're around the first time around. Okay, so okay, spec session complete. Let's see if we can see it on our UI. Follow link. Okay, no worries, cool. I think I know just the thing to adjust so you can see. But don't worry, before we get to look at the UI, first things first, we looked at where is one. We did we we started our Spark session and then started. Don't worry about, like I said, um there is a lot here. And when you are working with what's that error we spoke about? When you're working with your Pi for J Java error, you just read the bottommost cause, the last line. Or yeah, so you just see unexpected error code. Um Analysis exception detected, details unresolved column with a suggestion, a column variable or column parameter with name, non-existent column, unresolved, do more following. Yeah, you understand? Okay, it's a column issue. You go ahead, you check your column spelling, your column name, and yeah, so you don't bother going through trying to check all this or what's happening here. You can see, okay, this is what the issue is at the very bottom. Then went ahead to clean up our missing values. Where's our clean up missing values? Yeah, let me do this. I hope you can see it clearly. Is it clear? The chat is silent. Is it clear, people? Can we see it clearly? If we can't type, we can go ahead and use the emojis. Although I don't know if in this setting I can see the emojis now that I'm technically not on Zoom. So okay. Someone said, okay. So we went ahead, we said, okay, we got the error. Um, yeah, they're missing claim, missing value. Went ahead to tidy them up, replace them. You can see them here, null, and then went ahead to actually removed it from there, but so it doesn't affect whatever we're doing on our data set. And then went ahead to calculate, tax. So hold on a minute, sorry. No, why this setting is just okay. So we did our tax calculation. You saw the output, the fiscal plan, the salaries. I went out. We performed our partitioning, our caching, um, partitions after repartitioning, and then to coalesce, and then did our broadcast join from the sales. Okay, hold on. Let me move this thing around. Sorry, is my screen visible? Shagun, please, is my screen visible?
Yes,
Okay,
you're very visible.
okay. Sorry, excuse me, guys. I think I've Wait, particular setting. Hold on. Okay, Dennis, sorry, I see your hand is raised. Can you let me know what the issue is in the Q&A or the chat? Um, Come, I don't know what I thought right now, but yeah. Well, it's cool. It's cool. Um, where was I? Oh, my thought process. Okay, let me just start again. We initiated our Spark session builder. We started by setting our shuffle partitions to four stops, as we set our shuttle partitions to stop Spark from creating like 200 tiny default partitions for this because a very small data set. We're not importing a large data set. We did our schema check. We printed out, the data types upfront to prevent the analysis exception, syntax errors later. Pandas UDF in the comments to again to help to increase speed. It gave us at least a 10% increase in speed. You might notice it now because it's a small data set. Hold on, please. Okay, it's a small data set, but for larger data set, you get a 10% increase in speed instead of the slow row by row Python processing. And then use that explain, it prints the catalyst optimizer output to confirm that the columns are properly pruned. And then a repetition and correlating, you organize the various departments, the different data into the department buckets like our sales, engineering, and then it shrinks them into two clean output files without network shuffling. And then we call on our persist. Remember, our persist is to, you know, what do you call it? Save data even after we've cleaned the RAM disks. You know, the dot count triggers the actual computation and the show reads from the cache. So even after we've cleaned the RAM or disks, our data is still there. And then the broadcast join that distributes the small departments lookup table directly to all the workers so they can see it and work with it, completing the join with zero network traffic. So I'm coming. I don't know. Okay, just give me a moment. Let me fix this. Sorry, I'm supposed to be seeing the UI. Bear with me. Um, Hold on. Okay, just let me to save time. Let me just. I think I stopped the session before. Mm-mm, mm-mm. Okay, I stopped the session before, so I'm not giving it a chance to. Uh, okay, okay. Let's run it again and see. Huh, bear with me. Bear with me. I guess I press enter. and not um let's pick achieve achieve UI. That's visible. Okay. Okay. So yeah, we should have our 4040 UI visible soon. Bear with me. All right. Okay, let's run it again and check it out. Yeah, session run. Dang it. This so let me check if yeah. So good news. We can see our UI. Can we see our UI? Is it visible? So no, no, UI can see our job descriptions, the time, the duration, tags, number of the number that was skipped, the time, etc. Yes. Bear with me as I was trying to given the scheduling mode, first in, first out, um, the event timeline, what happened, when and what, if it succeeded, failed, or is still running, stages, the storage, and our secure data frame. Excuse me. So yeah, I think that's fixed. All right. So I'm glad we all know how we got here. The settings on our local host to monitor. I remember we said we use this especially when we're trying to debug one or two things to check it out. I can even look at the check out the SQL queries, but we didn't do much of that here. So yeah. Where was I? Yeah. Slideshow. So any questions? Any questions at all? Let me check the Q&A. Okay. Bear with me. Wow. Hmm. Um, Guys, bear with me. I'm trying to work on my Zoom. Oh, I can't see. Okay, hold on, please. When if you have any questions, please put them in the chat or in the Q&A. Let me try and see what the issue is. Wow. Hmm. Sorry, please, but I hope I'm still audible. Am I still audible, please? Can everyone still see my screen?
Yes, yes, you're the boy who can still see your screen.
Okay, thank you very much. I don't know what's happening. I'm not my Zoom is no longer zooming here. I can't even see some things, but it's cool. So we're in the Q&A now. So Sharon, can you see any questions in the Q&A? Although I'm checking, I'm not seeing any. Are there any questions, please? I think I'm still a panelist. Any questions, guys? Let me know. Are we still together? Do you understand what we did? Okay. I'm in the queue and I can see a question from Felix. So Felix, yeah, you're asking if MCQ 4.9 is solved. So you guys have observed after a couple of weeks we released the answers, right? Not that I choose to release. So if you don't see it there, it means I've not released it yet. Is that what you're asking, Felix? Please let me know. If that's what you're asking, let me know. If the solution for those MCQ has been released, I release them. Had to give at least close to a month or a couple of weeks after the deadline. Is that what you're asking, Felix? If is that what you're asking? If you don't see it there, then I've not released it yet. So after a while, maybe doing the by the time we get to the catch-up week, all the MCQs will be released and so. But if you're asking if it's an issue whereby you submit and you get zero, um, we're still working on it. We're still trying to get feedback. It's an Athena issue on the LMS. It's not your fault, but if possible, if you can do the supplementary test, that would be helpful too. That could come as a standing. Okay, yeah, I get it now. My mind just went there now. So yeah, maybe you try again, but don't worry if you did the supplementary test or you got a zero, don't worry, be at peace, relax. We are going to sort it out. You are cool, you are safe. Don't bother. It's just a little bug on the back end. You know, building and writing code for a lot of stuff at times tricky things happen and then but we are working on it. Oh yeah, you're welcome. You are welcome, Felix. You are welcome. Okay, okay. At last, okay. So for this module, this cohort, all your assessments are just the MCQs. All the labs we've done, anything I've told you to go and do at home is for yourself. You will not be graded on it. It's just if you want to do it, but I strongly advise you do it. All the project portfolios do it because it's your own, is what you get to show. After certificates, what you get to show to people that you are competent, you are capable, and you learned one or two things from the course. Yeah, I hope that answers your question. I'll be launching the poll now. Let me see if I can do that. Uh, okay, it appears I can do that. So yeah, the poll is out. Kindly let us know how you feel. Don't forget if you need support, answer base, fresh decks, and the a-hope is there for you. You are not alone. The community is here for you. Your next MCQ is due on the 4th of August. Don't forget to post your wins and your CV and all you've learned on LinkedIn and in all your spaces. I will see you next week. And wow. So you know what? This is good. I really enjoyed the first bit. So what I'm going to do is we'll go back and play the first one. For some reason, I don't know why I did that. But let's go ahead. Wow. Even this one too. Okay, that means I can play this one.
Piki piki mabelane. Girl, have you been to China? Just the way you want me is making me speak in tongue. Oh yeah, I done the Maya. Maya for your love, girl, I cannot get enough. I can't believe take it. Since you taking, I'm gonna take you from your taker. Call me Undertaker. And see me later to collect the wallet. Girl, I was searching till I found you. And when I found you, I swore that I won't search no more. Girl, I was searching till I found you. And when I found you, I swore that I won't search no more.
Sala, sala, gentleman, oh, big, 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 big. Picky, picky, my belane.
Girl, have you been to China? Just the way you whine me, is making me speak in tongue. Oh yeah, I done the Maya. Maya for your love, girl, I cannot get enough. I can't believe you take it. Since you taking, I'm gonna take you from your taker. Call me Undertaker. See me later to collect the wallet. Girl, I was searching till I found you. And when I found you, I swore that I won't search no more. Girl, I was searching till I found you. And when I found you, I swore that I won't search no more.
Sala, sala, gentleman, oh, big, 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 my belane. Sala, sala, gentleman, oh, picky, picky, my belane. Sala, sala, Tando and Lizzy, Tando and Lizzy, Tando and Lizzy, sexy girl. Would you come through and step it up? Run it up for me, flexy girl. Anything you want, I got you, girl. You love your